this is very important theorem that states if fz is analytic in a simply connected domain D and C is a closed contour lying in D, then the integral of fz dz along C is equal to 0. This we have to show. So let this C be the closed contour in the domain D. Let me fix the point z0 in the domain D and let z be the arbitrary point, that is equal to x plus iota y. And C1 and C2 are the contours which are constructed in such a way which is shown in the figure. Let z0 be the fixed point in domain D and let's choose an arbitrary point z in the same domain D. Then C1 and C2 are constructed as shown in figure. Let's define capital F of z to be equal to integral of f of z along C1, right? Then the integral of f of z dz along C1 minus the integral of f of z dz along C2, this is the result, integral of f of z dz along C1 minus C2. Now what is the meaning of C1 minus C2? See, if you look at this first rectangle, the integral along C1 is in this direction and the integral along C2 is in this direction, that is opposite to C1, right? Because of the opposite directions, for this first rectangle, if I need to take the integral along this first rectangle, then that will be along C1 plus C2, and because of the opposite direction, I have written here the negative sign. So we should write C1 minus C2, right? The integral along C1 minus C2 for the first rectangle. Is it okay, fine? Right? Okay. So this integral is equal to 0. Why? Because the integral along the closed rectangle is 0. If fz is analytic in a domain D containing the rectangle C and its interior, f of z is analytic in this domain that contains the rectangle C, right, and its interior, then integral of f of z along the contour C, now here contour C is a rectangle, is equal to 0. So I am applying this result. Here also we are having the rectangle, right, this pink colored one. Because f of z is, it is given to us that f of z is analytic in the domain D. That is having this rectangle with the interior shaded in pink color, right? And the contour of this rectangle is C1 minus C2, right? Here it is C, but here it is C1 minus C2 for the first rectangle, right? So that is why the integral of f of z dz along C1 minus C2 is equal to 0, right? So this is the reason for that. So therefore, the integral of f of z along C1 minus the integral of f of z along C2 is equal to 0. Because this is 0, right? This implies the integral of f of z dz along C1 is equal to the integral of f of z dz along C2. What is integral of fz along C1? It is capital Fz. That is, this is equal to capital Fz, which implies the integral of fz along C2 is also equal to capital Fz. So capital F of z is also equal to the integral of fz along C2. Let me mark this point as Z1. That is the last point of intersection of C1 and C2 between Z0 and Z. That is x1 plus iota y1. Right? Okay. Please note that the value of the integral from z0 to z1 along C1, that is along the red color line, is same as that of the value of the integral from z0 to z1 along this blue colored line, that is along C2. So the values of the integrals are same along C1 and C2. These two are same from the point z0 to z1, right? That is, the value of the integral of f of z along C1 is equal to the value of the integral of f of z along C2 from the point z0 to z1. From the point z0 to z1. Right, up to this, the values of integrals are same along C1 and along C2. Right? And from the star, the integral of fz along C1 is fz, capital Fz. And we have also proved that the integral of fz along C2 is also equal to capital Fz. So the values of these two integrals are equal to capital Fz. Let me take this value to be equal to k, right? From the point z0 to z1. That capital F of z is equal to integral of fz dz over c1 from z0 to z, right? Now from z0 to z1, the value of f of z is k. From z1 to z, what could be the value further? That we need to find. So this is equal to k from z0 to z1, right? And now further to z, the arbitrary point. So adding, now along this path up to this point, f of z1 is equal to, because I'm having z1 over here, so writing here f of z1, that is equal to f of x1 plus iota y1, right? So along this red colored path, what is constant? y1 is constant, right? So taking the variable x1 to be t plus iota y1 and dz1 is equal to, so this is derivative of t plus iota derivative of y1. y1 is constant, so this is 0. So this is equal to dt. So writing here integral of f of z1, that is f of t plus iota y1, dz1, that is dt. And now the limits. What is the value of t in terms of x? It is x1. At this point, what is the value of t in terms of x? It is x. So the limits are from x1 to x. Now to move from this point to this point. For this we take f of z. So that is equal to f of x plus iota y. Along this path, what is constant? X is constant. So writing x as it is plus iota, taking y to be the variable t. And dz is equal to dx plus iota t. This one. That is equal to, because x is constant, so d of x is 0 plus iota dt. So plus integral f of x plus iota t dz is iota dt. Now the limits of t. What is the value of t at this point in terms of y? It is y1. What is the value of t at this point in terms of y? It is y. So the limits y1 to y. When we solve this integral, we are getting the values in x. When we solve this integral, we are getting the values in terms of y, right? I need to use one result, that d by dx of integral of f of t dt, where the limits are from a to x, this is equal to, writing t, just replace this t with the upper limit. So that is f of x. So to use this result, I am going to derivate both the sides with respect to y here. So derivating k, that is the constant with respect to y, we are getting 0 plus, and when derivating the second term with respect to y, because everything will be coming in x, so the derivative is 0. Applying this result, we get f of, just replace with the upper limit. Iota is also multiplied, and this is nothing but your z. So this is equal to iota f of z. Think capital F of z with respect to y gives iota f of z. Curly f over curly y, I can also write like this, equals to iota f of z. Let me take this iota to the denominator. We get f of z is equal to 1 over iota curly f over curly y. If I multiply and divide by iota, I get iota divided by minus 1 curly f over curly y, or it can also be written as negative iota curly f over curly y. So that is, we are getting f of z to be equal to negative iota curly f over curly y. Please mark this as 1. Similarly, we also have to work on f of z equal to the integral of f of z along the contour C2, right? From the point z0 to z. So another case, right? From z0 to z1, this f of z is equal to k, right? So writing this equal to k plus, we have to work on further. From z1 to z. Moving along the path from this point to this point, we are having f of z1, that is equal to f of x1 plus iota y1. But for this path, what is constant? X is constant, right? So I'm writing x1 as it is and writing the variable y1 as t. So d of z1, so dz1 becomes the derivative of x1 plus iota t, and because x1 is constant, so this is equal to iota dt, right? So writing here f of x1 plus iota t, and for dz1 we write iota dt, and the limits will be written for y. What is the value of y over here? It is y1. What is the value of y over here? It is y. And moving along this path up to the point z. Along this path, we are having f of z, right? So that is equal to f of x plus iota y. Very fine. What is constant, x or y? We are moving along this. So what is constant? Y is constant. So I'm taking the variable x to be t plus iota y. So dz becomes dt plus iota y. Because y is constant, so this becomes dt, right? So this is f of t plus iota y into dt. And writing the limits of t in terms of x, what is the value of x over here? It is x1. And what is the value of t over here in terms of x? It is x. So this is from x1 to x. Now when you integrate this, you are getting the values in y. When you integrate this, you are getting the values in x. So let me now derivate this with respect to x. First we have derivated this with respect to y. And now we are derivating this with respect to x. So derivative of a constant gives the value 0. And derivating the second term, which is in y, with respect to x, gives again value to be 0. Right? Because we are derivating with respect to x. And this integral will give the value in y. So this second term is also 0. So rest to derivate the third term. So we are getting curly by curly x of integral f of t plus iota y dt from x1 to x. And from the result, this gives the value as f of replacing t with the upper limit, that is x plus iota y, right? And this is nothing but your z, so this is f of z. So we are getting curly by curly x of fz to be equal to f of z, or f of z is equal to curly f over curly x, marking this as 2. So from 1 and 2, we get f of z equal to minus iota curly f over curly y, and f of z is equal to curly f over curly x. Equating these two, we get curly f over curly x equal to negative iota curly f over curly y, marking this as 3. What is 3 representing? Yes, it is representing the Cauchy's Raman equations for fz. And the partials curly f over curly x, curly f over curly y, these are continuous. Why? Because f of z is continuous. So writing this, so what conclusion we are getting? That capital F of z is analytic in the domain D, with derivative of f of z to be equal to curly f over curly x, which is equal to fz from equation 2. So this is fz from equation 2. So f dash z is equal to fz, right? Let C be the closed contour and let ZA and ZB be the initial and terminal points respectively of the closed contour C. That means the initial point is equal to the terminal point as C is closed, right? Thus, the integral of f of z along this C is equal to, instead of f of z I am writing capital F dash z. The limits ZA to ZB, right? Reason f of z is equal to capital F dash z. So this is equal to f of z, the limit ZA to ZB. So this is further equal to f of ZB minus f of, okay, what is z of A? It is equal to z of B. Yes. So I am writing here f of ZA to be as f of ZB only, because these two are equal. So these two cancelled out and we are getting the value to be as 0. So therefore we are getting the integral of f of z dz along the closed contour C is equal to 0. Hence the result. Alright, thank you. Stay blessed.